Piece by piece, the Dreamliner is finally becoming an aircraft. But the hardest part is still ahead.
Once cured, the composite structure is strong enough to become part of a real airliner. But this enormous section is still only one piece of the puzzle. Several giant sections must eventually meet with extraordinary precision. A few millimeters of misalignment can create major problems later. Laser-guided systems measure the structure before assembly begins, making sure every connection point is exactly where engineers expect it to be. Now the moment arrives. Two enormous sections begin moving toward each other, slowly becoming
the Dreamliner is finally becoming an aircraft. But the hardest part is still ahead.
Now the Dreamliner gets its wings. These enormous structures must meet the fuselage with extraordinary precision. Laser-guided systems check the alignment before the structure is permanently secured. There is almost no room for error.
Once everything lines up, specialized tools secure the wing to the aircraft's central structure, turning separate components into one load-bearing airframe. With both wings attached, the Dreamliner finally looks like an airplane. But it still cannot fly, not even close. Behind the walls, thousands of wires, pipes, sensors, and control systems are installed. This hidden network will eventually control almost everything on the aircraft. At the front of the aircraft, another transformation begins. The cockpit is becoming the control center that will guide the Dreamliner through thousands of miles of sky.
For the first time, the aircraft's electronic systems begin waking up. Every display and control must communicate perfectly.
Inside the cabin, the empty shell slowly becomes a passenger aircraft. As engineers install the systems, passengers will eventually never notice. Then comes the landing gear, the enormous mechanical structure that must safely support the aircraft during every takeoff and landing. The Dreamliner is finally standing on its own. But before this aircraft ever carries a passenger, it must prove that every system works exactly as designed. Now the Dreamliner receives two of its most important machines, the massive engines that will eventually turn thousands of pounds of thrust into flight. The engine is lifted millimeter by millimeter until its mounting points align perfectly with the wing structure. Once aligned, powerful fastening systems lock the engine into place. This connection must withstand enormous forces every time the aircraft flies. But an engine is more than a giant fan. Hundreds of connections allow the aircraft to control, monitor, and feed this enormous machine. With both engines installed, the Dreamliner is beginning to look ready for the sky. But first, engineers must bring its hidden systems to life.
With external power connected, the aircraft finally wakes up. Thousands of electrical systems begin receiving energy for the first time.
Every switch, display, and computer must respond correctly. One failure can stop the entire aircraft from moving to the next stage.
Then engineers test the aircraft's moving surfaces, making sure the wings will respond precisely when the pilot commands them to.
Next, the engines are tested. Slowly at first, then faster. Engineers watch every vibration, temperature, and pressure reading. After thousands of components, countless inspections, and years of engineering, the Dreamliner is finally ready to leave the factory. The factory doors finally open. After years of engineering, the completed Boeing 787 Dreamliner takes its first journey outside the assembly line. Outside the factory, nothing is taken for granted. Engineers inspect the aircraft again, searching for anything that could compromise its first flight. Every control surface is checked one more time, because these massive wings must respond perfectly once the aircraft leaves the ground.
Even before takeoff, the landing gear must prove it can handle the tremendous forces of a real landing.
Then the engines roar. Thousands of pounds of thrust are produced while engineers watch every vibration, pressure, and temperature. Then the engines roar. Thousands of pounds of thrust are produced while engineers watch every vibration, pressure, and temperature.
Inside the cockpit, engineers test the aircraft's digital nervous system, making sure thousands of electronic components communicate correctly. The speed increases dramatically. This test pushes the aircraft close to the conditions of flight without actually leaving the runway.
After the run, engineers inspect everything again. The aircraft has passed another major test, but the biggest test is still waiting. Everything has led to this moment. The engines are ready, the runway is clear, and the Boeing 787 Dreamliner is about to leave the ground for the very first time. The moment finally arrives. The Boeing 787 Dreamliner accelerates harder and harder, and then its nose leaves the ground. For the first time, thousands of components built in factories are working together as one machine, and the Dreamliner is flying.
At altitude, engineers begin testing the aircraft's handling, stability, and control, carefully watching how the wings respond to the air.
Inside the cockpit, every measurement matters. The test crew watches the aircraft systems while the Dreamliner continues climbing.
The pilots gradually push the aircraft through different flight conditions, confirming that the massive structure responds exactly as engineers predicted.
High above the clouds, the Dreamliner reaches the environment it was designed for: efficient, stable, and remarkably quiet. While the aircraft flies, engineers on the ground analyze thousands of data points, searching for anything unexpected.
After hours of testing, the Dreamliner begins its return. Now another critical moment approaches: the landing.
The landing gear touches down smoothly. The first flight has succeeded, but the aircraft still needs extensive testing before carrying a single passenger.
The Dreamliner has proven that it can fly, but before this aircraft reaches an airline, thousands more checks will decide whether it's truly ready for passengers. Landing safely was only the beginning. Now engineers inspect the Dreamliner from nose to tail, looking for the smallest sign of stress. Because much of the Dreamliner is made from carbon fiber, specialized sensors inspect areas that the human eye cannot see. Every major system is checked again: electrical, hydraulic, environmental, and flight controls, to make sure nothing changed during the flight. The engines face repeated tests too, because reliability at cruising altitude begins with perfect performance on the ground. The wings are inspected for microscopic changes, confirming that the structure handled the forces of flight exactly as expected. This aircraft begins as thousands of separate pieces. Stay until the end, because you'll see how they become one of the world's most advanced passenger jet engines. Unlike older airliners built mostly from aluminum, the Boeing 787 Dreamliner relies heavily on advanced layer by layer. These materials are shaped into enormous curved sections. Eventually, these pieces will become the aircraft's main body. These carbon fiber materials are incredibly strong and lightweight, but turning them into an aircraft structure requires precision measured down to tiny fractions of an inch. Heat and pressure then transform the layered material into a rigid aircraft structure. Every temperature and pressure value must stay within strict limits. Even the passenger cabin becomes a test laboratory, where pressure, temperature, and airflow must remain precisely controlled.
Safety systems receive their own inspections, because when something goes wrong at 30,000 feet, every second matters.
Repeated ground tests push the aircraft again and again, confirming that braking, steering, and acceleration remain predictable under demanding conditions.
Flight testing continues until engineers have enough evidence to understand exactly how the aircraft behaves in the real world.
Each successful flight removes another layer of uncertainty. But before this Dreamliner can enter airline service, after thousands of tests, the final inspection begins. Every major component must now prove that it's ready for airline service. Engineers compare thousands of measurements collected during manufacturing and flight testing, searching for anything that needs attention.
Outside, the aircraft receives one last detailed inspection, from its composite skin to every door, window, and structural surface.
Inside, the empty factory shell has become a finished passenger cabin, ready to carry hundreds of people across the world.
The engines run one more time, the control surfaces move, and the aircraft's major systems are checked together as one machine.
The engines run one more time, the control surfaces move, and the aircraft's major systems are checked together as one machine.
After countless ground checks and flight tests, the Dreamliner completes its final validation flights, proving that the entire aircraft works as one.
The aircraft lands safely, bringing one of the longest journeys in manufacturing to its final stage.
From thousands of separate components to one complete flying machine, the Dreamliner is finally ready to begin its life in the real world. Now you've seen how the Boeing 787 Dreamliner goes from raw materials to a flying aircraft. But if you could choose the next factory to
One aircraft, thousands of parts, and millions of hours of engineering. If you want to see how the world's biggest machines are